afternoon. Good afternoon. Welcome to the City Council workshop on the Pier. I would like to remind folks that the goal here is to answer some technical questions today. See if we can get some few things off the table. And Amelia, do we have to do a roll call or anything like that?
Yeah.
Yes.
Here.
Gertie?
Here.
Kennedy?
Here.
Dudley? Hearn?
Here.
Here?
Danner?
Here.
Okay. Before we go to the agenda, Tish, is that an old light?
Yes, it is. I'm sorry.
Okay, we have a proposed agenda in front of us.
Where?
It's this about a half-inch thick packet. It says new Pier City Council workshop, technical questions and referendum options.
Move approval.
Second. Is this our agenda?
Yeah, proposed workshop format.
I mean, who created this?
Mr. Connors.
I just didn't see your title at the top. Didn't see Mike speak on there anywhere.
Okay. Okay, we have a motion and a second. And a roll call when you're ready.
Gertie?
Yes.
Kennedy?
Yes.
Dudley?
Yes.
Hearn?
Yes.
Nurse?
Yes. Okay, just as a moment of background.
Nurse?
Yes.
Cornell?
Yes.
Newton?
Yes.
Danner?
Okay. As a moment of background, we've had a series of letters over the last, primarily the last week, but some of them going back months, outlining some technical issues that the opponents wanted to raise. And the intent was to give as many of those concrete issues in writing prior to the meeting so that staff could outline what we've done to address those. And so with that, Mr. Connors, you have a presentation outlining some of those?
Yes, we do, and I appreciate the opportunity to respond to what staff considers pertinent questions as it relates to the technicalities of this project, and wish to kind of, as a bit of backdrop, as council knows, at the last regularly scheduled meeting, Chair Nurse had a new business item requesting that the Stop the Lens organization provide a letter outlining their technical concerns. That was done so in a letter from Mr. William Ballard dated 4/16. Mr. Ballard was helpful enough in clarifying a number of those questions that were provided in writing, and in addition referenced other deliverables that date all the way back to December 3rd of 2012. All of these items are included as part of the hand-delivered packet you were just provided. They can be used as reference points, and we are going to focus on the technical issues as voted upon for the purpose of conducting this workshop last week. More specifically, a motion was made by Councilmember Kennedy and seconded by Councilmember Newton to approve this workshop on this date, limiting it to technical concerns, and that our legal department provide an explanation of referendum options, and that any workshop presenter have professional/expert credentials. As City Council knows, at the next regularly scheduled meeting, we have scheduled the architect, engineering, consulting team to be here to present the results of the schematic design deliverables. So none of those individuals will be here today. Staff will be responding to these series of technical questions, to include myself, Mr. Raul Quintana, Tom Gibson, and Chris Balestra. The format, as approved by council, will provide staff this opportunity. With then the floor given to council to ask any questions of staff or of the project opponents. And then to avoid cross-examinations or rebuttals between staff and project opponents for the sake of taking advantage of this time that's dear to all involved. So, with that said, here's my... Okay, this always happens.
Just Councilmember Newton?
Is it pretty much like quasi judicial? Is that what you're going to do, the 10-10 and question?
No, the format is what's in front of you as recently voted upon. Oh,
It's technical.
one of my expert colleagues turned this unit on for me, so I say that tongue in cheek. The first part of what's been provided is, as you know, the opponents of the project presented to City Council the individuals and the credentials they possess therein. We have 26 individuals comprised of the architect engineering team as supplemented by city engineering capital improvement staffs and CDA staff, i.e. Chris, that include a wealth of different professional engineers, architects, registered architects, and experts in the areas of geology, metallurgy, and FDOT standards, and bridge work and pedestrian work. Project development phases. A number of these questions that were posed to us, if you go through the rather lengthy series of deliverables from the project opponents, are related to the design of the project. And I thought it was prudent to just take a step back to recognize we haven't designed the project. We are going to be asking council 2 weeks from now to approve launching into the design. But what's preceded us to date is a design competition that ultimately was cause for council to approve the concept as presented by the Malson team, called the Lens at that time, and now referred to as the New St. Petersburg Pier. And that was done, followed by a basis of design phase. So the questions we have received to date have been pursuant to the deliverable that this council received and acted upon called the basis of design. And that, in essence, is nothing more than a document that lays out how we're going to pursue the detailed design. What are the design parameters we're going to follow? Are we sure we can build this within this very rigid cost estimate that's been established? And to fortify what the project milestones and deadlines are going forward. 2 weeks from today, we will present to you that schematic design phase and a request to launch into the detailed design development, where we will have specifications and details generated as to materials, mechanical, electrical, plumbing systems, structural systems, followed by construction documents, which are your drawings and your specifications. All of that is supposed to take place over the next 6 to 7 months. It has yet to take place. Notwithstanding the fact that we're trying to respond to comments on design, of which said design is not yet produced, we feel that they are pertinent in nature and they do form a basis for launching into the detailed design. With that said, I'm going to hand it to Raul Quintana and then followed by Tom and Chris. One of the things I want council to understand is that there's been some alluding to city staff perhaps being in over their head and maybe functioning in a rubber stamp capacity as it relates to the deliverables from our AE team. We're to demonstrate that's really not the case. We're managing this project to the degree it needs to be managed. It's a very high profile, very impactful project to the future of this city and its waterfront. And we've taken it upon ourselves to mandate that our AE team engage experts beyond the design development team that was originally contracted for by paying for those experts out of their own pocket. We, in turn, have engaged experts that we've typically worked with over the years in the development of our trail projects and the reconstruction of our bridge projects and the structural capacity or lack thereof of the pier itself. So I hope to deliver to City Council a feeling of comfort that due diligence is of paramount challenge and fulfillment on the part of staff. So, Raul?
Thank you, Mike. Good afternoon. One of the subjects that we were asked to address is the canopy, and specifically the corrosion issues in the canopy, the service life of the canopy. And let me just begin by first acknowledging that we understand that this pier is situated in a very difficult environment. The team understands that the fact that building materials need to perform under this highly corrosive, very difficult environment is understood. So we put together a very knowledgeable group of consultants, and they've brought in some other additional experts to help us at the level of the project that we are at today. Also, before I get into the details, I want to just give a little bit of background on kind of what got us here to the decision to go with a recommendation for an aluminum canopy. In the basis of design, the team looked at several options, and the key to the canopy was taking into account the life cycle costs, the maintenance, the initial costs, and the visual impact. So the team considered a number of options. One was precast concrete panels. The advantage of the precast panels was that they could be prefabricated locally. There's some delivery cost advantages. They can resist the upload. They're heavy. But the heaviness also was a disadvantage due to the weight and the need to oversize the foundations. And also, in addition to those disadvantages, there's also the discoloration of the concrete due to mold and algae, the excessive formwork that's required, the difficulty to replace those panels, and just the overall maintenance. They also looked at lightweight concrete panels. Again, it's a great strength to weight ratio, long life. However, it's got complex connections and a very high initial cost, and also susceptible to some of the discoloration and mold and algae and maintenance. Also looked at, considered perhaps a fabric. The fabric was dispensed with fairly quickly. The ability for fabric to hold up under the extreme conditions over Tampa Bay just didn't work out. So with that, the team at the BOD stage recommended that the entire canopy be made out of aluminum. And in the BOD report, they recommended an aluminum alloy, the 5086 alloy, and I'll explain a little bit about that, with a high-grade Kynar finish, which is the coating on top of the aluminum, and all of that on a galvanized steel frame, targeted to a 75-year life. Those were the standards that we put out from the very beginning. Need to be able to survive and to last 75 years. So at the very beginning of the schematic design, once you authorize us to go into schematic design, the entire team from the Maltson, from the Bureau Happold, with Skanska, and including 7 members of city staff, met for 2 days to discuss the entire project. And we challenged and we questioned every aspect of this canopy. We questioned the aluminum. Could it all be made out of aluminum? Does it have to be a combination of aluminum and steel? How will it be maintained? What is our ability to access the assembly? So all those things were looked at, and we specifically requested that Michael Maltson reach out beyond the expertise of the design team and bring in experts that could influence the design, and really people who are specialized in metallurgy and the corrosion resistance of material. So Michael Maltson brought in 2 third-party consultants, one who is an expert in metallurgical science, the firm Norske Veritas, or DNV. They're a global classification society established in 1864, headquartered in Oslo, Norway, with over 300 offices in 100 countries. DNV actively researches and advises on safety, integrity, and detailing of ships, oil rigs, and water-based structures. The office we worked with is out of Columbus, Ohio, and they have metallurgists and corrosion experts. We worked with Mr. Dr. Jerry Koch, who is a PhD in metallurgical engineering. He worked on the failure investigations of the Deepwater Horizon, amongst many other things. Then on top of that, and that's our scientific metallurgical folks, Maltson brought in the firm with Janie Elsner, WJE. They're a national firm with 19 offices. They're here in the United States. They're engineers, architects, and material scientists. They're involved in the investigation of an analysis of engineering structures. Over 50 years, they've worked on over 75,000 projects, every single type of construction material, every structural system, every architectural element. So these teams, these experts are going to continue to work with the design team throughout the project. As Mike mentioned, we're just at the beginning of the design. They have commented on the assembly at this point. They've actually influenced the final design of the current design of the assembly, as I'm going to show you. And they are vested in this project. They're going to continue to work with the design team. So some of the general comments that we got out of the team received from these experts is, first of all, determining the exact aluminum alloy that's required here. And Tom's going to go into a little bit more about aluminum and the characteristics of aluminum, but the 5000 series alloy is the highest corrosion-resistant aluminum alloy that you could possibly find. It's frequently used in the construction and marine environments, and further to that, there's several different aluminum alloys depending on the composition of the chemical, depending on the magnesium content within the 5000 series. In the basis of design, we had looked at a 5068. What this expert's recommending is a different kind of alloy, a 5454, and the reason for that is the lower percentage of the magnesium content in the 5454 will eliminate the potential for possible intergranular corrosion caused by higher temperatures. Because we're not in the water, we're above the water, potentially susceptible to higher temperatures, that alloy is what's being specified. And again, the Kynar added to the coating of the aluminum panels themselves will further extend the life of the aluminum. So what I want to just kind of walk you through is the assembly as we are looking at it today. And again, this is schematic, still a lot of work left to do, and this is just one small section of the assembly. What's in blue is aluminum, what's in light green is galvanized steel, what's in red and yellow are bond breakers that are basically set up to separate the galvanized steel from the aluminum. So I'll walk you through this. Again, we're well beyond in this development of this assembly where a schematic design would normally be. On this particular piece, we would probably consider this level of detail coming further in the development of the drawings, but we are further ahead. So, but again, there's plenty of work left to be done. So the canopy is intended to be made out of common materials that are used every day. It's the way that they are put together that's unique, and it's unique because of the form is unique. The structure is not unique, it's the form that's unique. So there's two major elements to this assembly. One is the panel system. The panel system is primarily what's in blue above the T. That's the coating, the Kynar coating, the aluminum panel itself, and there's two panels, and the panels are going to be basically 5 feet square. Then there's the fasteners. In this case, we're showing rivets. The final fastener detail has not been determined. It could be a concealed fastener. It could be a different kind of rivet. And then there's also a waterproof membrane, and then a sub-panel below that. So that entire panel, the key to that is the waterproofing of it and maintaining that coating over the life of the system. Then on top, that panel is connected to the structural support system. It's essentially steel superstructure and the aluminum T. So I can walk you through it. The top two panels of the aluminum is connected to the aluminum T. The aluminum T is then separated from the galvanized L angle, and it's connected with a bolt. The bolt is run through a bushing. That bushing is also separates the galvanized bolt from the aluminum T, and then the galvanized L angle is connected to the superstructure below. That assembly is reversed on the bottom of the panel. So what you're seeing is a section at the top of the panel, then you'll have the same detail at the bottom of the panel. And this is just a more straightforward detail of what that's going to look like. The zinc coating on the steel at this point is expected to be between 4 and 5 mils. And on top of that, galvanized steel, that zinc coating, is going to be an epoxy coating. So it's a duplex system of both zinc on top of steel, which is the galvanization, and then an epoxy coating on top of that. And the key to this entire design is in the details. The detailed engineering, the detailed design to avoid crevices, to avoid low spots, to avoid areas where water can collect. Again, it's the top end of this is intended to be waterproofed. Appropriate drains are going to be created in the assembly. So all those design factors are taken into account. The folks that we have talked to in the industry do believe that we are going, and the intent is to obtain warranties on both the aluminum panel and the coating of 30 years each. At this point, I'm going to turn it over to Tom, and he'll step you through a little bit more.
Thanks, Raul. I'm going to talk a little bit about the materials on this project. I'm going to back up a little bit, starting with the bridge, and just say a few things about that. The bridge substructure and superstructure are typical precast and cast and plate concrete, reinforced concrete structures that will conform to DOT standards. The new bridge superstructure will be about 6 feet higher than the old bridge, and that aids us and helps us get us out of the splash zone. And the DOT currently requires a 75-year design service life for bridges, and that's our objective for this entire project. The proposed metals in the Pier canopy are low magnesium aluminum alloy designed for marine environments. These are connected to an aluminum T, bolted to a galvanized steel angle with a PVC or nylon bushing and washer, and then a permanent polyethylene bond breaker tape between the aluminum and the zinc coated steel to prevent contact with dissimilar metals. The canopy will be at elevation 29 to elevation 108, so it will be well out of the direct salt spray zone, which helps with the longevity of the project. After some research around our local area to look for galvanized steel and aluminum structures, I see that it's widely used in our marine environments, both for vessels and for structures. Aluminum is commonly alloyed with other metals to increase workability, strength, and corrosion resistance. Marine-grade aluminum is specifically designed for marine environments. The use of galvanized steel members for supporting aluminum structures, which need to resist high wind loads, is common with FDOT sign structures on land and bridge approaches, and the FDOT uses aluminum light poles throughout their facilities with galvanized steel anchor bolts, aluminum signs, and galvanized bolts. So throughout Florida, we have aluminum and galvanized steel together working successfully for the DOT. This slide is the galvanic series of metals. And the takeaway from this is, if you look at the very top on the left, there's a series of metals, magnesium, zinc, and aluminum. And the farther apart those metals are on this series, the more reactive they are. So you can see that zinc and aluminum are very close to each other. Zinc is extremely widely used as an anode. It sacrifices itself for the other metal and is used as cathodic protection. So zinc and aluminum are very close together. They are dissimilar, but they're on the scale, they're right together. They're brothers and sisters. The DOT doesn't take any special precaution to isolate zinc and aluminum. Our project, we want multiple redundancies in our design, and we've isolated these two materials to prolong the service life. Oops. The next slide is American Galvanizers Association service life chart. So this is a typical life expectancy for galvanized metal. On the vertical axis is time in years, time to first maintenance is when you start to see rust blooms on your product, and on the horizontal scale is zinc thickness in mils. If you look on the second line up from the bottom is our tropical marine environment. So the service life of galvanizing depends on the environment. The worst environment is the lower line, or industrial, with a lot of pollutants in the air. And the next worst environment is our environment, tropical marine. High temperatures, a lot of rainfall, and salinity. So we can see that between 4.5 and 5 mils of zinc, we should get between 70 and 90 years of life, according to the experts. Now, this is just a generic design table. What I've asked the design team to do is to do a specific analysis of our environment, including the pollutants in the atmosphere, the salinity, the chlorides in the air, the wetted time having to do with our rainfall, and it's very important, is the wetted time, and the temperatures. and they've agreed to do that. At this point, and the design is not done for this project, but at this point, they're proposing a duplex system. So the steel is coated with 4 or 5 mils of zinc, and that in turn is coated by epoxy coating. So you have a redundant protection for that basic structure. Now, power companies and the DOT have been using galvanized steel poles increasingly to provide wind-resistant structures. Aluminum is used throughout our marine environment, and typically we have a 5000 series marine-grade aluminum. It's corrosion resistant. Aluminum is corrosion resistant because it forms a protective layer, aluminum oxide, on the outside of the untreated aluminum. In and around water, aluminum will eventually develop pits, which are not structural in nature. The pits are limited in their depth because the aluminum oxide seals them, but they do create an appearance problem. So you will get pitting on uncoated or untreated aluminum. You will get crevice corrosion, which is very undesirable because it may cause staining. So anywhere water condensate can pool, you will get a little bit of corrosion. So our design has to be carefully detailed so that we don't have these issues. And we propose, at this point, a Kynar coating over the aluminum, which will seal the surface and prevent the pitting. So to sum up, and I'm going to show you some pictures of aluminum and galvanizing in our local environment. But to sum up, my role in this project as a third-party reviewer and also bringing in outside reviewers is to ensure that we have designed this project, very important project to me and everybody else, to achieve the desired service life, and it has to be constructed carefully with those details. I have pictures of galvanized and aluminum together. This is 4th Street and Gandy. That's a galvanized, unpainted, galvanized mast arm structure. You're very familiar with those. In town here, we paint them brown, but they're galvanized underneath for corrosion protection. In the background, you see an open web steel galvanized truss supporting aluminum message signs for motorists. This is Gandy Boulevard on the north side. This is a radio communication tower or TV tower. It's been there as long as I can remember. I've lived here all my life. It's painted steel. I'm pretty sure it's galvanized underneath. On Gandy Boulevard, there must be 5 or 6 galvanized towers in or around or near the water. This is a galvanized open web truss on the Howard Franklin Bridge approach. It's directly in the spray zone. There's one on either end of the bridge. DOT has used these galvanized steel structures for 40-plus years. This is an aluminum light pole. Sorry, it's not a great picture. Mounted on galvanized steel bolts, typical DOT. This is a Progress Energy galvanized steel pole on the Bayway Bridge. It was been there since the 1960s, right in this spray zone. This is an aluminum truss gangway plank on our new Vinoy mooring project. That's a 5000 series or 6000 series aluminum structure designed to resist the marine environment. There's another galvanized steel Progress Energy pole on the Bayway Bridge. Been there for as long as I can remember. There's another aluminum gangway plank on the Sunlit Cove boat ramp. We're recently completing our Maximo boat ramps as well. They have aluminum ramps. Wherever you go in the marine environment, you're going to see aluminum. For instance, our Marina Ship Store, there's aluminum window frames. There's a 15-year-old building. They've been functioning so far very well. And of course, our old Pier building has aluminum window frames. The Pier structure has aluminum window frames, aluminum awnings, and galvanized steel awnings and other fixtures on it as well. And I'll turn it back over to Raul.
The next item that we want to talk about is our understanding of the concern over the challenges of the configuration of the canopy and its location. And I understand that there's a lot of concern about the wind effect, the effect of wind on people, the effect of wind on the structure. And I'm going to try to explain to you where we are on the development of an answer to this process and this issue. And it's an issue that, like every other issue that's been brought up, we take very seriously. We know that there's, even today, you walk out on the pier, and there's significant wind issues. There's the reasons why fabric canopy structures don't last out at the pier. So understanding that, what we have challenged the design team with is to perform the series of tests that are required to determine exactly what the issues are. The analysis of the wind on the effect of this canopy is a very complex process, and it affects not only the structural design, but also the experience within the space itself. The initial wind loads, and kind of give you a picture of where we are today, the initial wind loads have been calculated on a desktop model to determine the initial cladding wind loads on the canopy itself. And that's to get us through the schematic design, to help us inform the cost of the project and where we need to be. The only way to truly predict what the effect on wind on a structure such as this is by putting it into a wind tunnel. That's done on every type of complex project. It's something that we anticipated doing. It's something that we plan to do. So the next series of tests will provide a wind tunnel to confirm the computational models and further refine the wind loads to complete the structural engineering on the canopy. All of this was scheduled to be done during the design development phase. So the next phase of the design, those detailed wind tunnel tests were going to be performed. In addition to the wind tunnel tests to determine the structural integrity and the structural uplift loads and confirm those decisions, the team is intending to perform a pedestrian comfort study to determine exactly what the effect of particular wind speeds have on the shape and character of the canopy at this location. So when the pedestrian comfort study is performed, there may be areas that we get back from those studies that say, okay, you need to look at this a little bit further. Here's some hot spots. You need to take some of these issues into consideration. And really, the analogy I have on this is just like everything else we've done on this project, we're not going to design a foundation for this pier without doing geotechnical tests. You can assume the foundation test, you can assume the length of piles, but until you do that detailed geotechnical test, you can't engineer the foundation. You have to, the foundation size, the length, all of that's going to be factored in with the results of those tests. Same thing here. Once we do the wind tunnel test, we will know what are the issues that we need to contend with and analyze those results and accommodate any changes within the design itself. We're not going to speculate what can or can't happen, what might happen in a very complex design like this. It has to be put through a wind tunnel test. So the pedestrian comfort study is going to let us know if in fact we have a problem and what technique do we need to use to solve that problem, just like we've done with every other element of this design. There are tried and true methods to solve issues with wind. And I'm not going to get into the specifics of those because, again, I don't know what the test results are going to say. The next element that I want to talk about is the permitting on the new pier. And what I've highlighted here are just the codes that we have been working quite diligently with our building department and our fire department to make sure that this project complies with all fire and building codes required. And under any normal project, we probably wouldn't be delivering detailed plans to the fire department, the building department, until we are well underway with construction drawings. In this case, we have been meeting with the fire department and the building department for months. We've had at least 5 separate meetings with both. So we are well ahead of where we would normally be on just about any other project, recognizing the uniqueness of this project and the difficulty. The fire code is administered and enforced by the authority having jurisdiction. In this case, it's Chief Mike DeMonte, and Chief is here. He's our fire marshal. We've also met with the building official, and we intend to have full compliance with life safety, Florida Building Code, ADA, and all other requirements. So the materials on this pier. First of all, it's classified as an outdoor assembly. The materials are classified as non-combustible, type 2 construction under the building code. And these are materials that are used every day. Again, the pier is not a unique structure. It's a unique form. From the foundation up through the deck, which is nearly 75% of the structure, it is a conventional FDOT bridge. So what the specific things that we've looked at in order to ensure the ability to fight fire on this pier, and again, it's all non-combustible materials. We're going to have a 6-inch fire main provide water from the land to the end of the pier. We've got fire hydrants located in 3 separate locations, and then standpipes on the opposite end of the marina, all of this meeting the requirements of life safety. In addition, there's going to be an occupant notification system at the hub so that from an emergency perspective, fire can, or anybody can announce an emergency on the pier and evacuate the pier. All of the enclosed buildings, including the concessions and the restrooms, will have fire suppression, fire sprinkler systems. Additionally, there will be fire extinguishers. A number of questions have come up about the dimensional criteria and the fact that this pier does not meet the dimensional criteria for the fire department. The requirement is a 20-foot minimum horizontal clearance on the overwater drive in order to provide fire access all the way to the back of the pier. At every point where there's a vertical issue, there needs to be a 13-foot-6 minimum vertical clearance. The first one's going to be where the overwater bridge overlaps the overwater drive. From the deck of the overwater drive to the underside of the structure of the overwater bridge, there needs to be 13-foot-6, and we meet that requirement. We meet the 20-foot clear all the way around the pier. And also underneath the canopy. The canopy, and you'll see it on the May 2nd when we show you more details and more actual designs of the canopy and the layout, that at every location we have the 20-foot wide clearance between the columns around the, and underneath the canopy and over to the turnaround. The fire truck itself, working with the fire marshal and the fire chief, it's been determined that the apparatus that's going to serve the end of the pier is the fire engine, not a ladder truck. And the pier is designed for a load capacity of 40,000 pounds. The fire engine's 36,000 pounds. So the whole pier is being designed around the ability to provide a fire engine to the end of the pier. Again, the turnaround issues, the end of the pier at the promontory, there's a 70-foot diameter clear turnaround with a 20-foot clearance horizontally so that fire engine could make its turnaround and it meets the turnaround radius is required for that engine. At the welcome mat, the radius is 120 feet, so the fire department can bring the ladder truck up to the welcome mat and it can meet their turnaround requirements. So the one issue that we have actually spent the most time with the fire department and the building department is on the whole issue of egress, getting people off the pier and evacuating the pier safely. So what was looked at in order to determine this whole process, and again, this is 4 months of work, multiple meetings, a very sophisticated software program and I'm going to just go through the highlights on this because it'll take an hour just to explain it. The issue is how do you, first of all, determine what the occupant load is of the pier. And working with the building department and the fire department, we've looked at each individual component and applied an occupant load for that area. For example, the gathering areas that you can hardly see, but it's in orange, is based on 7 square feet per person. Other areas have a little bit greater area per person. All of that has been reviewed and approved by the fire department conceptually at this point in order to establish what that occupancy is. Based on that occupancy, then we know what to plug into the model, and the issue is how wide do these pathways need to be to effectively evacuate this many people. And this occupancy load is based on the worst case. This is a special event, 4th of July, on this pier, first night. These are the days that, you don't have, this doesn't happen every day. On a given day, you might have 1,000 people, 2,000 people, but on a special event, this is the occupant load that's been determined that is the basis of our design going forward. The next thing we looked at is the travel distance. Okay, what's the length that it takes you to get off the pier from the end? And the model is based on evacuating the pier based on the egress width in a reasonable time. So the issue is, well, how do you determine what that reasonable time is given the widths that we're working with? So what we're trying to do is determine, and there's a couple of aspects of this. One is creating a safe zone within the structure that people can evacuate to. If there's a fire out, say at the promontory, the distance that a fire is from the safe zone is something we'll have to determine. The time that it would take for someone to evacuate that area to the safe zone, and the time to completely evacuate the pier. So we looked at 3 scenarios. The first scenario is just the normal evacuation. Forget about fire incident, but say it's bad weather or security incident. How long does it take to get people completely off the pier at a 5,954 occupant load? The second scenario we looked at was, what if there's a fire at the promontory? How long does it take for people to get to a safe zone, and how long does it take them to completely evacuate the pier? And the third scenario we looked at is, what happens if there's a fire truck as an obstacle on the overwater drive headed towards the fire at the end of the pier? How long does it take people to get to a safe zone? How long does it take them to evacuate the pier? And I'll just show you a little bit more about the model itself. The model is, again, very sophisticated. It requires the development of a demographics and plugging into the model the percentage of people that maybe have different mobilities and different ages, children, older people, and putting into that whole mix, how long does it take for each of them to conceivably move and find their way around. And this is just kind of a snapshot of what the model does. This is looking at a fully loaded condition at the end of the pier on the promontory, and all those little spots are plugged into the model. And each part of the pier has been allocated its occupant load based on the occupancy count that we showed you a little bit earlier. And so the question is, if there's an event on that fire event at the end of the promontory, how long does it take? And this is what the model predicted. In 2 minutes and 25 seconds, that area of the pier could be evacuated. Those occupants could get to a safe zone away from the fire. And finally, the model for each of the scenarios, the total egress time on the scenario 1 was 13 minutes and 14 seconds. Under non-emergency, under a scenario 2 with the fire at the end, again, 2 minutes and 25 seconds to get to a safe area, and then 13 minutes and 14 seconds to fully evacuate the pier. And in the scenario 3, with an emergency vehicle obstructing the overwater drive, it takes a little bit longer to get off the pier, 18 minutes and 26 seconds. I know that's a whole lot of technical information, and believe me, there could have been a whole lot more, but the summit, there's a lot of work that's gone into the determination that this pier can be safely utilized, safely evacuated, and fire can access and provide fire protection for this facility. And with that, I'd like to just ask Chief DeMonte if he just takes a second if he has any comments.
Thank you, Raul. I just wanted to speak briefly, if I could, about my involvement in the project from the Fire Marshal's office. And I was very happy to be engaged by the project development team to come to us early on, as they're just starting to launch the idea of the new pier project and gain our input and our involvement. It's very rare in a project of this size that we get in this early, so to speak, and help in the development phase. And really our job is to make sure that regardless of what brings a building forward, once it is brought forward, we need to build it safely and in compliance with the Florida Fire Prevention Code. So I've been very happy and pleased to work with the design team and the members of city staff that you see here before you today, because they have accepted our input, and we have talked about a lot of significant issues regarding building the building safely, our egress issues, our life safety concerns, our ability to effectively fight fires and handle emergencies and disasters out there. So I just want to offer that as we move forward here. I've yet to see any official plans that have been developed and turned in for review. We're way too early for that, but I just want to let you know that I'm very comfortable with working with the team that we have so far, that they're taking our suggestions to heart and really doing the best they can to put forth a very safe and well-designed facility. So just want to share that with you folks. Thanks.
We're under a time crunch here, and I'll kind of try to get through the next issues fairly quickly. The next issue is the overwater drive and the lack of physical separation between pedestrians and vehicles. First of all, the standards that we're using to design this bridge and this drive is based on the use of the facility. And the use of facility is as a pedestrian and bicycle use, with the only vehicles being allowed being the tram, emergency vehicles, and service vehicles that will be controlled by the city. So it was never intended that the two bridges function as a bridge for vehicular purposes, but rather as a pedestrian shared use access with the tram. So the use really is what dictates the infrastructure. In the basis of design, we had shown a 20-foot clear width minimum, meeting the fire department. Now that we are in schematic design, the design right now shows a 22-foot wide bridge. So we've widened the overwater drive, 22-foot wide overwater drive. And again, it's intended to be primarily a pedestrian right-of-way. And the section that I'm showing you is just one option of how the final layout could occur. But under this scenario, what we're showing is 10-foot wide minimum path down the middle for the tram, and two 6-foot wide sections on either side for either bicyclists or pedestrians. The key to this whole issue on understanding the conflict, or the perceived conflict between people and bicyclists and vehicles, is that the tram, which is the number one vehicle that's going to be out there daily, probably every 15 minutes there's going to be a tram out there, needs to be part of the experience. The tram needs to be extremely slow moving. It needs to be open air. It needs to be part of the experience to get out to the pier. The tram will be limited to 5 miles an hour. Just to give you an example of what that means, it will take 3 minutes and 36 seconds, according to the feet per second, at 5 miles an hour to get from the beginning of the bridge to the end of the promontory. That's less than 4 minutes at 5 miles an hour. There's no hurry to get to the end of the pier. So the idea here is that you're going to have a very slow-moving tram. The other issue is that the current pier trolley, the red trolley, has exceeded its service life and is scheduled for replacement. That trolley is now used for charter service and will continue to be used for that. However, that trolley is not what's intended to be used for the pier. So we're working with transportation staff and the rest of the city staff to look at replacing that trolley on the pier with an eco-friendly trolley. We're looking at a trolley that's not going to be more than 6 feet wide, a trolley that can handle speeds no more than 5 miles an hour. And it's going to be an open-air trolley, and there's multiple examples of that at the right time we're going to plug in the transportation staff and really look at this issue from the usability and how do you get people safely to the back of the pier on the trolley. Service vehicles will also need to be authorized by the city. So if you've got a service or you need to do something out at the pier, you're going to need to have your vehicle authorized. You're also going to need to be, go no more than 5 miles an hour. The pedestrian will have the right-of-way in this design at all times. With that, I'm going to turn it back over to Tom, and he'll go over the DOT plans.
Yeah, just real quick, I wanted to go over the bike ped design requirements. This project is being reviewed by our in-house engineering staff as well as outside consultants. So we're engaged in getting third-party reviews of the design. We've engaged Sprinkle Consulting, which is our bike ped expert, and also Parsons Brinkerhoff, a national transportation expert. And we've gotten preliminary opinions on this schematic design that given the operating conditions with the pedestrian-friendly, slow-moving tram running down the center, we don't need a vertical separation or curbing to separate the pedestrians from that tram. So think Disney World, Main Street, USA, Disney World. They've got a They've got a trolley going down the street is packed, and it's very slow speed, and everybody coexists. The trolley will stop if there's a pedestrian interference. So that's where we're headed at this point. And as far as guardrails, at this point, we don't think we need to have an H20 rated guardrail. We're going to continue to look at that aspect since it's not open for the general public. It's just a controlled pedestrian and bike bridge with the trolley. At this point, we have a 42-inch high guardrail, pedestrian guardrail. And the other issue was the width and the 22-foot width for the overwater drive, and then the upper bike trail bridge is 12 feet wide at this point, and those both conform to DOT standards.
Just have one more thing to go over, and turn it over to Tom again and then to Chris. The other question was the overwater bridge, the high bridge that crosses over the drive. In the basis of design, it was shown as 10 feet. 10 feet is the minimum width in the DOT standards, the Manual for Uniform Standards for Design and Construction, and a shared pathway with bicycles and pedestrians. 12 feet is preferred, and we've been working with the design team, working out the budget, and in the schematic design, we have increased the width of that bridge to 12 feet, and that is, again, it exceeds the minimum standards, and we all feel fairly confident that that's going to work. The guardrail at the overwater bridge is 52 inches high. Another question that came up was the question of the ramp at the end of the bridge and its slope and its location. And basically that ramp hasn't been completely designed. And one of the reasons why we're holding off on the detail of that is because of the design of the Columbia restaurant. It's going to have a lot to say about that ramp's location, the configuration of that ramp, how it's going to be handled. So we recognize the concern. The intent is obviously that, you know, when you get to the end of the overwater bridge, you're probably going to have to dismount your bike and walk your bike down that ramp. It's not intended to be a ramp that you're going to, you know, easily ride a bike down. So we still have some work to do on that. We recognize the issue, and we know that that's something we're going to have to deal with going forward. Tom, did you want to wrap up and then turn over to Chris?
Just as a way of example, this is our new Clam Bayou Trail. We have 5 bridges. The longest one is 700 feet, and it's 12 foot. It's a pedestrian facility with pedestrian railings, and it was designed with an H10 vehicle loading so that we can run service vehicles down this facility when needed, and also if we have to rescue somebody, we can run an EMT truck down that trail to pick up somebody that's had an accident or something. So that's just an example of the kind of design thinking that we go through. The base substructure is capable of supporting all the vehicles, but it's a pedestrian facility. Yeah, that's right. And as far as the slopes and on bike trails, this is a ramp on the Pinellas Trail at Tyrone Boulevard, 12 feet wide with a handrail, and the slopes conform to the standards of the day. And here's another one at Tyrone and Park Street. So we'll be designing our facility to meet the standards and the operational considerations that we require. Chris?
Thank you, Tom. Chris Balestra, City Development. Just to cleanse the palate for a moment, while your focus today is on the technical issues, there has been a question or two raised, and things have changed a little bit, I believe, for the better relative to what's happening on the projected financials for the new St. Petersburg Pier. When we presented basis of design, there's a forecast subsidy in year 1, which would be 2016, of $592,000. The 10-year average, $666,000. That was the subsidy presented to you at that time. The average subsidy today for the last 10 years has been about $1.4 million. The most recent closed out year last year is 1.38. So that just sets the table as to where the numbers are today versus where the projections are tomorrow. Projections are just that. They're forecasts, they're pro formas. They're built on assumptions. and they are guaranteed to adjust, change, and evolve subject to design, expense implications with the design, and the revenues associated with them. To that end, a very big change, and I keep my comments brief because we're focused on technical, not numbers, but between December and today, of course, we're all well aware that the Columbia Restaurant has submitted a proposal to the city. In an abundance of caution, we published that and invited competitors to be a part of this process for a landmark waterside restaurant. No competitors or alternative proposals were submitted. We're in the negotiation process right now with the Columbia Restaurant, and we look forward to bringing forward a lease to you in June. The Columbia Restaurant proposal, as you have all seen, had a reduced rental rate from the basis of design rental rate proposed in December. And that is understandable and also a good reason why maybe nobody else submitted a competing proposal. The limitations are for a 10-year lease on this piece of land, and it's for a restaurant that the developer will not own. So effectively, they're writing a very large check, $3 to $4 million, and paying rent, and they'll never own the building, and they're betting that they will have the ability to have a lease renewal or ask for a referendum down the road. So it's a very high bar that is set for this piece of land. The Columbia has stepped up, and they're willing to do that. Their reduced rental rate did, in theory, lower the revenues to the pier. But remember, at basis of design, as I noted earlier, it's an evolving process. In a very conservative fashion, we did not program in revenues for the Promontory Grill or even the ice cream shop out at the end, not knowing at that time what we were really working with. The net result is even layering in the Columbia revenues as proposed, and the negotiation is still underway, the subsidy level as presented up on the screen does not change at all. One thing I haven't noted, those are the revenues. This project is not driven by the revenues on it. It is a completely different asset, 90,000 less square feet of surface area, pedestrian oriented, and it is not designed to force the revenues to support the expenses that it'll take. It's designed to have minimal expenses, as minimal as possible along the way. There's no one has ever asserted that there will never be a subsidy at this asset. The subsidy issues are what really kicked this project off 3 years ago at your direction. That said, we mirrored the expenses in the subsidy numbers and particularly the expense numbers presented in December. They mirror today's pier numbers with adjustments for appropriate sizing. They even include, for example, the exact same number we're using for the tram today is the number that we used starting in 2016. And it's anticipated that it could be a very different, more efficient, ecologically friendly tram system at that time. So again, just in an abundance of caution and in an attempt to be ultra conservative on expenses, we've arrived at what we feel is a comfortable expense number. It will change. We will continue to update you as it changes. But the long and short is that with the Columbia adjustments as proposed today, not approved, we effectively have a no subsidy impact based on what you saw in December. So with that, I'll turn it back over to Mike.
Thank you for your patience and indulgence. I'm just going to wrap it up with a brief summary. The issues regarding the canopy, we hope we have addressed based on third-party involvement on review of the technicalities that the AE team has produced, based on city review of commonly used materials in the environment that we traverse and use on a day-to-day basis here in South St. Pete, or in South Pinellas County. The wind tunnel effect and what that may produce. I could understand trepidation on the part of City Council launching into a detailed design without greater assurance that if there is a Venturi effect creating undue wind to the users of the pier, what are we going to do? Well, our consultants have given us examples where spoilers, bafflers, and other features can be incorporated into this project, either on the back end of the canopy or at grade itself, to effectively mitigate any heavy wind loads that are created from the canopy shape and the bridge itself. Fire code. The bottom line is the fire marshal has indicated he sees no fatal flaws based on the information he's been provided to date. And until such time as detailed plans and specs are provided for him to issue a permit, he cannot guarantee that he's going to permit it. But once again, working with our fire marshal in concert has proven to be appropriate as this project advances toward conclusion. The bridge, is it a pedestrian bridge? Is it a vehicular bridge? From day one, the concept has been this is a pedestrian bridge, and therefore it's being designed to those relative standards. What the project opponents have not had opportunity to review, which was given to them just here and today, is the fact that the overwater bridge has been widened from 10 to 12 feet. In Bill Ballard's email that was received just yesterday, that was a big concern he expressed. We hope we've adequately addressed that by the dimension he's recommended. The overwater drive, where we have tram and peds and bikes all sharing, has been increased from 20 to 22 feet, thereby addressing a big concern that the project opponents have brought to our concern. And then ultimately, there's a general concern about warranties, guarantees, et cetera, et cetera. The materials we're proposing in this project are no different than what exists in our environment today. We would not get a warranty that we expect to get for this aluminum canopy and its respective coating if it were a concrete structure. If it was cast-in-place concrete, if it was precast concrete, we don't expect to get the type of warranty that the producers of the aluminum have indicated that they'll provide us if we do indeed go forward with the detailed design of such a canopy. So we feel comfortable that we've got a cost-effective canopy, and we've got a very valued, engineered, and appropriately quality assured and quality controlled project as we go forward. And with that, Council, we'll answer any questions that you have of us or the project opponents.
Okay, I don't have any lights at the moment, and that's never had that experience before. So let me start with Mr. Ballard and ask him to give me some.
I had a light there, Mr. Nurse. I don't know if
You didn't when I started my sentence, sir.
Oh, okay, well, finish your sentence and look at the board.
Thank you. That's very kind of you. Mr. Ballard, if you would go over the issues that you're concerned about in terms of the canopy and the Venturi effect. I mean, to me, sort of on the face, that appears to be something we have to address.
Chairman Nurse, it certainly does, and it appeared to be an obvious defect that made us wonder why, with all of the skilled people that you have on your staff, that you are hearing serious discussion about this for the first time today. Perhaps there has been a presentation before. I don't know why. We wondered early on why the city was going forward with bridges, the contest-winning bridges that were 8 feet wide for the upper bridge, and I believe 18 feet wide for the lower bridge. It was instantly obvious that there was going to have to be a fire department access road, and it was basic that that would have to be 20 feet wide. We did not intend to present in this vein today. I came here to really stick to the technical issues and not get into what I'll call the argumentative side. It is a bit difficult to resist. The canopy, the statement has been made, it is not a unique structure. On, I believe it was a December meeting when you were approving whatever whatever the hundreds of thousands of dollars were for this design phase, that the question was asked, well, show us a like structure. Possibly it was Mr. Risser that asked that question. You have received letters from him pointing out that each and every one of those examples did not represent a comparable or light structure. We don't have time to rehash that argument now. But there is what is in essence a hollow metal tank. And there are many ramifications that come from that, primarily the trapped condensed air inside that tank that differentiates it from any exterior light pole or any other structure that is not trapped in a tank that may heat up to 100 degrees and hold all the moisture that that will hold, and then cool down at night to create condensation that, together with bird poop, rat droppings, and everything else that will accumulate in there with time, and excuse me for being crude, but this is the way it works, you start bridging these wonderful, and that's an elegant design. Mother Nature has a wonderful way of bridging those gaps. Mr. Cairns is here to address that further. That's his business. The state fire marshal, if I read the fire code correctly, not the local authority, is the person who passes on the adequacy of the turnaround. I had a call one day at my office from a law partner. Bill, your pickup truck is on fire out on 34th Street. Well, Bill's pickup truck could have caught fire anywhere. It could have caught fire parked under the, if it was the service truck out there working on the elevator on this structure, it could be burning there. Query, how does one of those giant fire trucks come out and turn around if something has blocked up the turnaround out there? It appears that it would have to back 1,500 feet to get off this structure. We do not have a quarrel with the structure of the bridges. We do have a quarrel with the concept that you can build these as pedestrian bridges. If you're building them as pedestrian bridges, nowhere do we see in the budget anything that is going to control the access on these pedestrian bridges. In your basis of design book, you mentioned food trucks out there. I mean, we take our cues from what these people publish. Food trucks, service vehicles, buses were mentioned for transportation to and from getting people out there. Revenue, $2,000 a week from large gatherings out there. I would assume that you are going to have pressure from people wanting to go out to weddings and limousines and all kinds of special events and all the excuses to get to drive their vehicle on that pier for a revenue-producing event. That's certainly not, management of that problem does not appear in your budgets. We have a very conflicting picture. We've learned today what finally occurred to me last night about 9:30, and it was acknowledged that your $6 or $7 million upper bridge, the one that flies over the lower bridge, and was to have been a pedestrian, a pedestrian and bicycle shared use path, now has a ramp. And I just want to point this out. This is what you were looking at in August of 2012. There was this upper bridge ramp that gave a clean departure. from this 29-foot-high bridge if you're on a bicycle. So what have you gone to today? Now, the FDOT says you should plan for 20-mile-an-hour bicyclists. Well, your 20-mile-an-hour bicyclist is hitting about a 100-degree turn and going down a ramp that has to level out every 5 feet, every 30 foot of length. It's going to have a 5-foot flat spot. This is a pedestrian ramp at the end of what purportedly was to be a bicycle and pedestrian facility. I ask you council members to consider whether that facility is worth $7 million to the city of St. Petersburg.
What was the,
I have provided you.
what was the last question, Mr. Ballard? What the last question you just posed? No, I get the 100-degree turn.
Is that facility worth $7 million to the city? That upper bridge, which is essentially a pedestrian bridge.
Okay.
Now, it was stated that the 12 feet wide for that upper bridge is a preferable width. I'm sorry, sir, but in the documents that I provided you in December, it flat out stated in both the structural guideline manual and in the FDOT plans preparation manual that a shared use path bridge had a minimum requirement of 12 feet. So if you wonder why people get skeptical of what is being presented to them, that is a first-class example. What you advance money for the next design phase with a feature like that had been brought to your attention by my communication of December 3rd, and no mention was made of that to you at the meeting. That is why we take it upon ourselves to try bring these matters to your attention, and what we had hoped dearly and was to have you all discussing these matters informally rather than the show and tell. I would like to ask Mr. Cairns to step up and address the issue of why this is a unique structure from an engineering standpoint. I have provided, and this ties in with the memorandum I provided you, that you own the risk if this engineering experiment fails. You have a memorandum that explains that designers like Mr. Cairns do not guarantee results. They are only obliged to use the standard of care prevalent in the community for their profession. That means if this project will not provide 10 years of requiring no repairs to the structure, if it fails to last 50 or more years, or if a hurricane takes it down, the city has the risk. You can't go back on the designer and you can't go back on the contractor, because if the contractor builds it in accordance with those plans and specifications, representing the best good faith efforts of a good design team, you get nothing. You get yourself in the same position that Tampa Bay Water was when they lost their $100 million claim 1 year ago today against the designer of their reservoir, because they couldn't prove that the designer failed to meet the standards of his profession when he produced defective plans. Mr. Cairns, please.
Good afternoon.
Yeah, no.
Some of you people know me pretty well. I I started out in life as an aeronautical engineer. I spent since '71 in the construction business one way or another around St. Petersburg. But for about 5 years, I was in charge of engineering at a company called Nautical Structures.
Do you have a resume in our packet?
Oh, I think you do.
It wasn't provided in your
Yes.
packet, it was
Yeah.
provided previous, when
Yeah.
the original letter came in from Ballard with the attached.
We have one, we're good, go
You should
ahead.
have it.
Thank you.
Okay. For 5 years, I was in charge of engineering at Nautical Structures up in Largo. We designed and manufactured aluminum structures that are used on very large private boats, up to 350 feet in length. I have an extensive experience in dealing with aluminum in marine environments. It is true that the particular alloy that you use is important, but we're talking about a coated system in this case, coated with a product that's generically called Kynar. And the Kynar finish isn't intended to protect the aluminum, it's intended to make the product look good. It's very susceptible to filiform corrosion at the edges, which disfigures the material and ultimately leads to pitting corrosion of the aluminum. You were shown a series of highway signs and light poles and things like that. For the first time, I've seen some idea of how the intent is to assemble the canopy. There's supposed to be a steel structure and then an aluminum panel system attached to it. Today was the first time I'd actually seen that. The big challenge here is that the canopy structure is not an open-air galvanized steel structure supporting an open-air sign or other device. What you see in those presentations are things that do indeed have long service lives. They have long service lives because they're not continually subjected to salty moisture. They're out in the air. After the rain washes the salt off of them, then they dry out. So I have no doubt that one can design a highway sign that will last a significant length of time. The canopy structure, on the other hand, is an enclosed structure. It's basically a big tank, as Mr. Ballard mentioned earlier. And being out on our bay, it's going to inhale warm, salty air in the morning and the afternoon. And in the evening, the water's going to condense out of that and collect in the bilges. Over time, we'll get an accumulation of salt and other debris in there that will bridge the proposed separations between steel and aluminum. The galvanic table that they showed you was only a part of what you need to know. I spent 3 years over at USF working on a doctorate in corrosion. Rust is my favorite color. I can tell you that when this structure is, if we build it the way it's shown, when it's first built, the zinc on the galvanized steel will be the anode. It will be the part that corrodes. The aluminum, even if it's exposed, if the paint has a chip in it or something, the aluminum will be the cathode. In a corrosion cell, at the anode, the metal dissolves. At the cathode, you can't see anything happening. There are reactions going on there, but they don't affect the metal. As the structure ages, the situation will reverse. When all of the zinc is used up, the steel becomes the anode, and the aluminum becomes the cathode. It's quite an interesting situation that will happen over the lifetime of this product, if you indeed build it. Now, we have asked before, is there an example of a similar kind of structure that is an enclosed system, steel supported with an aluminum skin, top and bottom, anywhere in a marine environment in the world? I make my living advising condominium boards on how to maintain their buildings. And I have people come into my office every week with some new super duper product. And my answer to them is always, give me 10 people that have had your product in service here in Pinellas County or South Florida for 10 years. So I can call them up and see, well, how's it going? It never happens because it's a new super duper product. When you do a unique project like this. And I've designed some really unique stuff in my career. You really have to look at the basic fundamentals and decide for yourself, do I know enough about what I'm doing to take the risk that it's not going to work? I said I was an aeronautical engineer when I started out. I've done wind tunnel tests. I'm familiar with the whole process of wind tunnel tests in what are called boundary layer wind tunnels to simulate turbulent wind near the ground. Usually we're measuring surface pressures on a model of a high-rise condo, like any one of the ones you see on Beach Drive. But in this case, you need both to measure all the surface pressures and also the overturning moments and the twisting moments that are generated by this unique shape in a hurricane, given the wind is coming from every possible direction. And once you have those forces available to you, then you can begin to do a design. In my view, if we want to do this thing, the very first process that you need to do is tell these guys, stop drawing pictures. Go do wind tunnel testing. Figure out what the forces on this thing are going to be. Because until you have that data, you can't design it. And if you can find something that really is like this, I'd like to go see it. But going out and looking at a highway sign on Gandy Boulevard is not anything similar to this. Looking at a radio tower, it's all exposed to the air. It dries out. It's not enclosed in a tank. And this is a serious difference between what you're contemplating doing and what you've been shown as examples. That's, in a nutshell, what I can offer to you. I tend to be too professorial when people ask me questions, but I'm quite happy to answer any technical question having to do with corrosion, different kinds of metals and sorts of things like that you might have.
Thank you, sir. We've got several lights, so let me start with Mr. Newton.
Thank you. My question is for Mike Connors. You want to come back up?
Okay.
Thank you, Mr. Chair.
Wait, we're not done, are we?
They want to talk to Mr. Connors.
At one time, they talked about, I think most of them was talking about building some models or some mock-ups to test some of this stuff, because it's never been done anywhere in the world, from what I understand, this design. Is that being done? Is that going to be done?
Yeah, Raul indicated that part of the project scope of work is already contracted with and to be performed is to conduct a wind tunnel test.
But no mock-ups on anything else is being done, or did I just read something?
No, that's also going to be looked at going forward. We have not constructed any mock-ups at this point, but yeah, the intent is as we go forward that there will be mock-ups to look at exactly how this is going to work in the environment that it's going to.
So absent that data from wind tunnel testing and mock-ups, the numbers you're throwing at us are just your interpretation of what this project might do? Is that a fair assessment?
I agree with Mr. Cairns. A wind tunnel test is really the only way to determine what those factors are. So that test hasn't happened yet. The process that we set up at the very beginning was to have that happen at design development. There's been numerous tests performed during the schematic design. We will present that in 2 weeks. We've had geotechnical tests. We've had wave analysis. We've had a significant amount of work done during the schematic design phase, assessing tests. The wind tunnel test, we needed to get through a little bit more design and engineering to determine the configuration. The configuration of this canopy has been, worked on during the design. And let me just kind of backtrack on something that Mr. Ballard is mistaken on. He's pointing out concepts in the competition as if those were final designs. The competition, all that did was get us to the point of beginning where we can start a design. The design, then we went through a process of developing the basis of that design, and now we're designing it. So everything that was presented in the competition, that was a concept that was to get us to the point where we can start designing with a world-class qualified team.
Let me repeat something, because maybe I heard you right. You said that there's numerous tests that's been done, and you got data and whatnot, and you're going to present that in 2 weeks?
No. The test, the wind tunnel test won't even be authorized unless we go forward and are authorized to commence with the design development phase.
But you just said numerous tests.
Tests
What is that? What are you talking about?
during the schematic design phase, which you authorized us to enter into, we've done geotechnical tests, we've done wave studies, we've done a series of surveys, we've done underwater sonar surveys, we've done a significant amount of tests to further advance the design in schematic design. That will be presented to you in 2 weeks.
That's where I'm going. I mean, we're here at a workshop to talk about specs and designs and put some of these questions and speculations to bed. And you bring pictures of signs, you don't bring all those tests?
No, I mean, I'm answering the questions that were brought up by Mr. Ballard.
No, but...
And that's the extent of the questions that were
but
asked.
my question to you is, sir, we have a workshop set up for specs and to try to put a lot of these, what they call it, untruths to bed. And you got certain tests and stuff that you already ran, so you got stuff you know as a fact because of stuff you've done, and we don't disclose that in this
I'd
environment.
be happy to disclose all that, but that would take a whole lot more time than what you've provided to us to address the questions that we were asked to address.
I'm just a little curious as to why we wouldn't have that information if it's all about, just putting all the nonsense to bed. Because it sounds like you got quite a bit of stuff and still no one knows. So my next question is, Mr. Rao, you made a comment about, you said the design of the overwater bridge will, hang on, I can't read my own writing. The design of the overwater bridge will have to wait on the design of the Columbia restaurant.
No, what I was referencing to was the ramp at the end of the overwater bridge, which Mr. Ballard showed.
The bike bridge.
Yeah, the ramp that takes you off the overwater bridge.
Well,
Its location and its design is going to be affected by the design of the Columbia restaurant.
okay, so that would have to wait for the Columbia restaurant.
Yeah, we're obviously need to tie the two together.
My question is, why can't all of these designs wait until the voted on waterfront master plan be rolled out? People already voted on that on my election petition. If we're going to wait for something, I mean, that seemed like the logical step for the master plan. So none of this is contained on the waterfront master plan?
I'll let council address that question.
That's really not a technical question.
Okay, and this one will go to Mr. Balestra. He spoke about the lens design. It was not pushed to produce revenue, but need a subsidy. Could you elaborate on that, please?
Yeah, the design as proposed by Michael Maltzen took into serious account the concerns with subsidy that had been expressed for years about the current pier. And so the forces of expenses control were factored in, and then again validated by a third. We did an analysis, and then we had it validated by Willis Construction Estimating out of Orlando, again, in a pro forma basis. So the expenses were focused. That said, there's ample revenue opportunities over and above the existing proposed restaurant square footages, marina revenue opportunities that are out there. And that was clearly noted in the Willis report as well.
This, I'm just going by what you just told me. I found this out. You mentioned something about a lease in June. You're throwing a lot of stuff out, so I'm just trying to get some clarity.
Understood.
Stuff that you spoke about. I wrote it down. You said reduce rent adjustments for the Columbia. Doesn't that equal less revenue? Is that appropriate? Is that appropriate assessment?
Yes, the Columbia's proposal, which we hope to bring forward as a lease to you in June, is a lower rental rate than we had predicted. In the Willis report, in fact, it's just as clear, and I'll restate it again, it's always anticipated that we may undercut the rental rate as help in providing a building that somebody else is going to build for the city. They're building a building that they will not own. $3 to $4 million asset that becomes the city's on day one. So with no 50-year lease, the 10-year lease. So to answer your question very specifically, we had pro forma'd a $25 per square foot rent on the waterside restaurant feature. The Columbia proposal came in at $15 per square foot.
And you said the subsidy on the pier is currently 1.2 to 1.4?
About 1.4 1.4 last year, 1.38,
So the last one you saw 3.8?
the last one, last year.
Well, let me ask you, I got this question here, and it's, this the book you guys gave us, it's pretty thick, on, and it's got the specs, November 26, 2012, you might remember this.
Yes.
There's a page in the back here that says, and I quote, says the annual deficit exposure from the $1 million existing Pier subsidy, 1.5, that number's been thrown around a lot. So why is it, if you say the highest you saw was 1.38, why do we keep talking about 1.5? And the reason I bring that up, because you have a layout here from 2016 to 2026. And it talk about the operating expense in 2016 to be $939,300. That's the operating expense. Maintenance being $22,000. And it says subtotal of expense is $961,000. Now the revenue, it says is $369,041. Is that the amount that we're gonna get from the Columbia? Is that the revenue on the land side you're talking about?
No, there's additional revenues that help make up that number. The Columbia, as presented in that report, as well as where it is today, whether it's Columbia, whether it's a bait shop, whether it's an ice cream stand, the collective revenues together total that number that you reference.
So that reduced rent is not gonna affect that 369 that you're proposing in here?
It doesn't for a couple of factors. First of which, and I thought I mentioned this, but again, being extraordinarily conservative in that estimate, there was no revenue recognized on the promontory, what at the time we considered a quote-unquote promontory grill. The Columbia would like to put an open-air restaurant out there. So those revenues were not captured in that basis of design. And there's additional revenues that were not captured there as well. So now, as time goes on, people come to us and have an interest in the project, and there's a possibility that could happen. It gives us a little more comfort that those revenues may be real at some point.
Could I ask you?
Councilmember Newton, we're going to start city council in 27 minutes. I've got a few more lights. Can I let some other people ask some questions
I'm
and circle
finished.
back around?
I'm wrapping, 2 seconds and I'm done.
Okay.
The lease, the lease that you're bringing, that's the only one we have proposed. You say in June you're bringing that back.
Hopefully.
How much revenue would that be? Just a ballpark, if you know.
For the Columbia,
The one you're gonna have signed, the only one you got, yeah,
close to $200,000.
$200,000.
Okay, thank you.
Thank you, Mr. Chair.
Councilmember Curtis?
Thank you, Mr. Chair. And I want to thank you, Chair, for having this workshop, getting it together. I think it's important that we get as much information discussed in the open. And I'm sorry if you feel this is too formal. I feel this is a good opportunity to get information. And I want to thank Mr. Ballard and Mr. Risser and Mr. Cairns and all those who have asked questions and keep pointing to things that we ought to be paying attention to. I don't view that as necessarily being anti-lens as much as I view it being pro make sure you do it right. And I don't think the two are mutually exclusive, to tell you the truth. So I appreciate it. I do appreciate it. I want to make sure I understand a couple of things. Canopy. I'm gonna make a statement. Tell me if I've captured it. There's two primary issues. One is the dissimilar metal construction issue. You understand what I'm saying?
Yes, sir.
The other issue, as I read the correspondence and listen to the explanations, is the fact that this is a unique design in terms of wind loads and structure, and that's something to pay particular attention to because it's never been done before.
Yes.
In terms of its shape and wind loads and wind speeds and directions and all that.
And the two problems of corrosion and the structure intersect. The engineers have the challenge. They can come up with a great structure. I am convinced they can build something that will stand and not rack and torque and fall apart.
Okay.
But then they have to solve the problem of this condensation inside,
Okay.
and where they might want to put a rib or something. No, they have to redesign to avoid that, and they are having to do it along a curve where the problem of water entrapment in
I got it.
Paris. which leads us to,
You're taking up my time now.
this is an experiment. One word, experiment.
And by the way, if we build this, I was going to say when we build it, but I'll say if we build it. I'm thinking the Overwater Bridge ought to be the Bill Ballard Overwater Bridge. So, because you will have done a lot to make it the best it can be. I'm just kidding you.
Please don't.
If you could, I mean that, I mean it humorously with all due respect.
You want me to move to Colorado?
I don't want you to do that. I like you too much. If you could go back to the connection picture where it shows the panels, the T, the girder, if you could go back to that. I'm having trouble understanding, and I'm not an engineer by any means. I'm having trouble understanding the tank analogy from the picture. It shows panels,
It's on our program.
a waterproof.
Yeah, let me, she could get it up. on the-
When they're describing it in a tank, I'm picturing some air in between, and I didn't see that from the
Yeah,
picture.
What
So
you
I'm
saw
trying.
was the top layer. There's also a bottom to that. So
Okay.
it's two surfaces, a top and a bottom. And all we show.
And is there air inside that can't get out?
It's intended to, it's going to be ventilated. It's
Pardon?
It's going to be vented.
It's
It will be
vented.
vented, yes. Yeah, so we haven't gotten far enough into the design to
Okay.
solve that problem, but it will be vented. As a matter of fact, that's something they're looking into with WJE. There's potentially ways of venting it with openings in certain areas, so it's going to be internally drained, it's going to be vented, and, it is, again,
Okay.
these are great questions. These are
Yes,
absolutely
I agree. I
perfect
totally
questions.
agree. I totally agree.
And we're looking at it. It's just part of the process.
See, from that picture, I was saying, okay, all that stuff's going to sandwich, and there's not going
What
to
you're
be
not
air in
seeing
there.
is, it's a very complex design, and to show you the whole
Okay.
thing would have been a little bit
You
longer.
explained it. There is an opening, but it's supposed to be vented, and
Yeah,
you
there's
think.
going to be the
Okay, so we can
the
discuss
tank
that later.
concept.
I was just trying to understand it. The last question I have is, there was also a question, well, the question wasn't talked about in the, there was a question in the correspondence, Mark, about the use of TIF funds over 30 years. Did you happen to catch in the correspondence? I can talk to you about that later.
Yeah, but we are authorized by the county to use TIF funds, and we can bond them out to the extent that we are authorized to, which is, I believe, a 30-year bond issue.
Okay, I'll get with
But
you
I can
later,
get
but that was an issue that was raised in the correspondence and on. Thank you.
Thank you. Mr. Connors, was that the question you wanted to answer, or no?
Yes, it's been answered.
Okay. Councilmember Kennedy?
Thank you, Mr. Chair. And Michael, Raul, Tom, Chris, thank you for your presentation and all your hard work in this. And Mr. Rizzard, Mr. Ballard, and all your team. I echo what Charlie had said as to thanking you for your involvement, understanding that this is done out of the passion and love for our city. And so thank you for stepping up and being concerned enough to step up. I guess my one question to you folks is, the question is not did city staff answer the questions to your satisfaction? The question is, did city staff address all the issues that you feel you raised and expected to hear them address?
My mind is not good enough anymore to answer. My mind is not good enough anymore to accurately answer that question.
Yes.
I'm sorry. This is why I quit trying cases.
Well, and I guess I just want to make sure that tomorrow or next week, there's not a new issue that we didn't think about or we didn't get a chance to consider because something brand new is popping up. That's really where the direction of my
Let me
question
defer to my colleague.
I tried to raise the real issue with this canopy design when I spoke. What they're showing you is a very interesting assembly. They're not showing you the complete assembly that makes it into a tank.
Well, they're
And-
doing that because we're not to that step yet,
Yeah.
right?
No, let me say, from the ability to build this canopy is critical to the project. And to have failed to do any preliminary wind tunnel tests already, I find to be appalling risk. The things that they've been looking at are pedestrian engineering things. That's not what we have here. We have a very interesting structure that success demands that we analyze the forces that are going to act on it very early in the process. It doesn't do you any good at all to wind tunnel test a thing halfway through construction drawings and find out, oh my God, we can't make it work. That is crazy. And the other issue is they're mixing steel and aluminum inside like an enclosed container in a marine environment in a way that I've never seen done. And so go out there and build something and see what happens to it. Instrument it. There are people over at USF that can help you with that. I worked with one of them, Dr. Segues, in his corrosion laboratory. That's what you need to do before you commit millions of dollars on a venture like this. So no, they have not answered the really important questions.
Mr. Connors, you wanted to say something?
Michael, can you respond?
Yes, I appreciate it. I think it bears the brutal bluntness that arguments are being made on false pretenses. We had a 10-foot wide overwater drive that is 12-foot wide. We had a 20-foot wide a bridge that went from 10 to 12. We had a drive that went from 20 to 22 feet. Now we have the presumption that the canopy is going to be enclosed, it's going to function like a tank, it's going to collect moisture on the inside and therefore deteriorate from inside out or vice versa. That's totally wrong. It's always been planned that this canopy needs to be ventilated. We need to circulate air through the canopy, top or bottom or intermediate spaces in between, longitudinally or vertically, in order to accommodate the need to ventilate it. We recognized that from the get-go when we started looking at the structural steel members and how to avoid webs and H-beams and I-beams from possibly collecting moisture and having it reside there for any length of time. We are keenly aware of the need to remove moisture buildup inside this canopy, and it was never intended to be designed as an enclosed vessel. So that you just need to feel assured that that's the case. In terms of the accusation that we're taking it out of sequence, until such time as we could confirm the form of the canopy, what is its shape, what is its dimensions, where is it going to sit in relation to the bay, we cannot conduct the wind tunnel test. Once that form is completed in the schematic design where we are about ready to present to you, we can then put it in a tunnel. We can build a model, put it in a tunnel, and then conduct the necessary tests. So we are doing this the proper sequence. Form first, wind tunnel section, study second, and then how do we abate any inconveniences to the users through baffling or spoiling devices, or how do we modify the structure to accommodate excessive winds that may build up. So we feel that this is being undertaken in precisely the right way you would from a sequential standpoint.
Thank you. Mr. Pallett, did you want to add something to that?
Yes. I was slow on the uptake on the first time, but a question relating to the fire safety. The fire code requires that any bridge utilized for a fire department access road must meet national standards for such a bridge. And a question is out there regarding the guardrails. Will the state fire marshal permit this thing meaning the overwater drive, with pedestrian bridge guardrails, or will the state fire marshal require the benefit of the much heavier and more expensive guardrails associated with a bridge for vehicles that meets national standards? I'm not raising this as a big stop the world issue, but it is an issue that I do believe you need to address.
Thank you. And Michael, do you have a response to
The
that?
state fire marshal does not possess the jurisdiction to oversee that aspect of the project's compliance with fire code. That resides with the local fire marshal.
And once again, just thank you for your involvement and time and dedication to this. Thank you, Mr. Chair.
Councilmember Curran.
Thank you, Mr. Chair. I'll echo the thanks to Mr. Ballard and Mr. Cairns for coming in with your technical questions and the staff for trying to answer those. I just have one question to Mr. Cairns. I know that your details are regarding the mixing of the steel and aluminum and the assemblage and all of that. I just wondered what projects have you designed or what design teams have you been involved with that have done a project such as this? Can you tell me what you've
Well,
done?
I tried to make it clear that I know of no similar project in the world.
So you've never done anything on this scale is what I'm trying to get at.
It's not a matter of the scale. It's the basic fundamental system of mixing steel and aluminum
Okay,
in a
thank
marine environment. I've done a lot of smaller scale aluminum structures in the marine environment where we've encountered lots of problems.
I read your resume. Thank you.
Yeah.
Councilmember Dudley.
Thank you, Mr. Chair. Mr. Connors, I want to make sure that everybody understands, this is a typical sequence in the design process, is that correct? What we're doing, you design, you test, and then construct?
Yes, sir.
This is typical.
It's typical as it relates to this canopy because of the unique shape and form of it. Until such time as we confirmed that unique shape and form, geometrically, dimensionally, it didn't make sense to conduct a wind tunnel test because it was subject to change.
And you know, I heard when doing the original presentation here a little while ago, I got that about the airspace and the air flowing through. It makes sense. I mean, obviously I'm not an engineer, but and speaking of that, I would just like to say that for those who don't know, Mr. Connors is an engineer by trade. And Mr. Connors is very well, highly credentialed, and I really respect what you say, and I know that you have done a thorough job on this, and by the presentation you put together today with Raul and all, it has cleared up some things in my mind. And I would like to say that I'm glad you answered the question on the fire marshal, because our fire marshal knows what the state regulations are and so forth, and I have the utmost respect for them and the jobs that they do, and I'm sure that they wouldn't put anything up there that wasn't state approved or whatever, and I'm glad you cleared that up. I want to thank Mr. Ballard, Mr. Cairns, and the group. You guys, we've met, several times, many times, and I really do appreciate. And I ran into one of your colleagues I went into a store, and as typical discussion started, we got involved in this, and he made a comment that I do want to address, because I know that there's still people out there that think that we're not listening, and I caution that individual. We're listening, but because we don't necessarily agree, doesn't mean we're not listening, we just don't agree. And I hope you understand that. We've got, Mr. Connors has put together a whole list of people, you showed us at the beginning there, involved in this process. And, this is like one of those things when you go to court and you have your expert witnesses, you have them on both sides, and, I look at, and they're very well credentialed, as is Mr. Cairns. I read his bio, and you, sir, are very well educated, Naval Academy and lawyer and all, and I appreciate that. And we put together a group that that I feel very comfortable with, from very well credentialed also. And I think that the questions, some of the doubt, and I took notes today. I learned some stuff here, and I think that that idea about how we were going to get transportation and pedestrians and bikes and all that out there, now it makes sense. It kind of cleared it up a little bit today. And but I won't belabor the point. I just want to comment that thank you very, very much, Mr. Ballard and Mike and your staff. Thank you very much for working for the city.
Councilmember Cornell?
Yeah, thank you. Thank you to Mr. Ballard, Mr. Cairns, Mr. Risser, and the whole crew for being here today. And I think this has been a good exercise in public discussion and certainly productive. Is it true, I don't think he's here anymore, but is it true that Chief Diamante approves? Oh, he's here. Oh, good. Come on up, Chief. Let me ask you a question. Who approves the final construction plans for this project from the fire codes aspect?
Okay. Before I answer that, let me just touch on kind of the authority having jurisdiction thing.
Okay.
The State of Florida Fire Marshal's office is ultimately responsible to give us our Florida Fire Prevention Code that we use throughout the state of Florida, and they monitor the activities of fire marshals throughout the state.
Okay.
That book in and of itself, and the mayor has referred to it as our Bible, he's seen it, it's quite thick and very detailed. Throughout that book, many, many times, you'll see the term authority having jurisdiction. That is placed with the fire marshal for each local jurisdiction.
Okay.
And we ultimately are charged locally to enforce that code and gain compliance with it here locally. If there were, for example, a disagreement between our office and somebody that's trying to build a structure and they didn't agree with my interpretation of the code, there's been cases where they've appealed to the state fire marshal for a declaratory statement that says, well, what does the book say? What is he enforcing? What does it really mean?
Okay.
And ultimately they do come back and give that. But we have no disagreement here. I'm working with the city officials on this, and things like our turnaround, for example, I ultimately have the responsibility to make sure that our vehicles can turn safely out there, and that rests with me.
if somehow fire codes are not being taken into consideration in the design of the project and something slips through and you look at the construction permits, the final construction plans, which are not done yet, it's not there's a couple more phases to go before we get to that point. Do you have the authority to say, no, you're not constructing this?
I have the authority to,
without some changes,
to determine that they're not meeting the Florida Fire Prevention Code and it has to meet that standard, yes. To answer your question, yes, I do at some point have the ability to say, no, this is not acceptable and we need to make some adjustments.
So construction
it's
doesn't
part
happen.
of the process. It goes through the building department and through our department and several others to determine that we're meeting all the appropriate codes and state laws. We are part of the process. So yes, my part is to look at life safety code issues and things that affect our discipline.
Okay, so to me that feels like, to put the check by that one, I mean, to me that's good enough, because that's we do hundreds and hundreds of projects where our fire marshal looks at them. I mean, to me that's a check. To me that technical issue can be taken off the table. Fire code will be met or construction will not start.
It will be, and as I mentioned earlier, I'm very satisfied with the progress that we've made. There are no fatal flaws as I see it at this point. I'm very satisfied with the give and take that we've had in this pre-design phase, if you will.
Okay, and then I just have two more quick questions. Could somebody describe for me, I know I was at Lake Vista about April 1st, and there's a very unique design they have for that rec center, and they put it up there, and he said, anybody can do a computer schematic. Don't think because we have an elaborate looking picture that this is a done deal. We want public input. And nobody said, oh my gosh, you're changing it as you go. It's a flawed design. I mean, the architect, Tim Clemens, said that's a normal process. Can somebody explain to me exactly where we are in this process as far as that you have a design phase, you do make changes during that phase, and then you reach a point where changes should stop and the construction drawings should be complete. Am I understanding that correctly, or am I not understanding that?
This is no different than any process on any project that either we would do or any other municipality would do. The process, in this case, began with the basis of design to determine not only can the concept be built and can it be built within the budget? That was the purpose for the basis of design, and to determine exactly, what we were going to do going forward. From that point forward, we began the schematic design, and through this schematic design, there's a series of back and forth and further evolution of that concept and details of that design. And once that's done, the next phase, the design development, is to take all of the systems, the mechanical, electrical, the plumbing, the structure, start to really define that process, and then develop the construction drawing. So it's a very formalized process, and each step has a purpose, and that's exactly what we're following.
So I think that's one of the things that makes me feel somewhat comfortable. I like the questions. I think they're good questions, but also comfortable with the idea that there's a design phase where people are giving input, because I've seen, when I worked for the city, a lot of projects where there was a lot of input for a while, and then all of a sudden it reached final construction, and then it moved forward. So then there quit being input because they were constructing it, and to me, that's a normal part of the process. My final question to Mr. Cairns, when you spoke about and thank you, sir, for being here. When you spoke about the condo associations and you would advise them not to use new products and not to do new construction type of techniques, I guess my question is, though, that seems almost a natural conflict, and it almost seems like you're saying we should not build something that hasn't been done before. And yet, I guess my question would be, isn't that in the American Institute of Architects agrees with this, because they sent us a letter saying exactly this. Isn't that the point of an international design competition, to get something that's never been done before?
Well, I don't disagree that you're trying to get a design that's unique. The question is, are the way that you achieve the design, are they unique? And it's one thing to make an extension on something that you've done before, where, okay, I have a case that's very similar to this, and now I'm going to take another step and introduce an extension. What we have asked is, where is there a similar kind of structure? It doesn't have to be this beautiful looping design. It could be something very mundane, but some situation where there is a steel framework that supports an aluminum skinned thing in a marine environment like Tampa Bay. And that we've had people show us highway signs. And I tried to make it very clear that the environment that a highway sign is in is much different from when you enclose it. And of course you have to vent it. That was the most ridiculous statement.
And finally, if I could just ask staff for a list of all the Penny for Pinellas projects over the past 25 years. I think we probably have those lists. How many were done that we said we were going to do? How many were on budget? How many were over budget? Because one of the things that's been tossed around very casually by probably, I don't know, I bet 100 members of the public have told me the city never does anything on budget, never completes a project right. And I have to just say the actual facts of that matter are quite the opposite. So if I could have a list, some type of list that you have, not anything new that you create, but something that you already have, I'd like to be able to share that information. I think that's important.
Thank you. Councilmember Danner?
Thank you. And I just want to echo what everyone said, thanking Mr. Ballard and Mr. Risser for taking this time, going into this detail, and for the staff. I know this has taken a lot of their time as well. Certainly, if nothing else, we know this is an incredibly complex project that is very detailed, has a lot of elements, but as you can see, it's being worked on. And I think it's great that it's a unique, one-of-a-kind project. You know, building a concrete block and stucco terracotta building over the water in 1919 was very unique in a city where 95% of the buildings were wood. Certainly, the inverted pyramid was a very unique structure. Construction's changing. It's changing since I've been in it, and I haven't been as long as these gentlemen, but when I started my architecture and design classes, my to-do list was to buy a pencil and an eraser. I actually owned a slide rule. There were no computers. That's changing this industry. The Salvador Dali Museum, the challenge is there to put a priceless art collection in a flood zone prone to hurricanes. They found a way to solve that and still have this glass enigma where no two panels are alike, no two metal structures on that thing are the same. You know, just the old post and beam and joist and walls. It's all different now. And every one of these projects has, These beam and rafter systems were no two are alike. They're designed on the computers. They're built. They are becoming the tested and the normal. So I think it is great that this is unique, and I think these issues are going to be resolved. I said the staff is doing good. I think the updates we're going to get from the design team and the construction team and the input that we're continuing to get from the public that changes this concept into a design is what we set out to do from the beginning, and I think everything has just gone down that path exactly like we wanted it to do. You're never going to make everyone happy, but just the fact that it is changing, it is listening. There are restaurants now, there are things to do, there's components that will continue to change. I've seen the designs of the transit vehicles, a couple of them that are being proposed. It is neat. They're not going to be yellow trolleys like downtown. They're going to be something new and unique fitting of a structure like this. So I think it's good. I think it's great. And again, just want to thank everyone for staying so involved, staying so critical, and making sure that this is a great project.
Just as an FYI, folks, we are running out of time, so let's try to be respectful of each other's time. Councilmember Newton.
Thank you, Mr. Chair. I want to thank everybody for coming out, too, and all the people that took the time to come out and speak. But I want to clarify for the record, this has never been done before. So when someone asks a question of anybody in here and asks them their credentials, have they ever built something or worked on something this big, the answer is no, for our city staff and that, because no one can tell me they put up a canopy over that big over water anywhere in the world, because it has not been done. So I think that point is mute. Let's get that out of the way right now. I can tell you that in the design phase, yes, you get more input and you start critiquing it, but as things go away, like underwater garden that you can go out and experience and see the sea life in, and then motorized boats, when all that stuff goes away, shouldn't the price come down too? I mean, I'm not the smartest guy in the world, but the price is still $50 million. So, I mean, I agree that when you change things and you do different stuff, you go from concrete to aluminum, you know, that and try to make that work and make it unique, that's great. But I like to see the dollar amount come down with it. And I think that not having the test done ahead of time, I'm not an expert, but I do know sequence, because if we do the sequence and wind test the canopy and it don't work and it can't be abated to make it work, that money is gone forever. That money does not come back. That's the problem you have when you don't do it. Early on, I think it was last year sometime, Molson talked about building models and testing them. He said it. But we're going to do it after we spend the money. And then we're going to try to make it work. And if it don't work, I don't know what we're going to do. So that's my take on it. Maybe I'm missing something. But I appreciate everybody for coming out. It's your pier. It belongs to you. And you will be voting on it on August 27th, from what I understand from the concerned citizen. So it'll be a great day. Thank you.
Thank you. Councilmember Curran?
Thank you. And if we do vote on it on August 27th, I think it is really our responsibility to make sure that the public is educated about this project, the process, all of the things that we discussed today. I think that the citizens need that accurate information to base their decision. And as recently as today, we receive emails on a daily basis on both sides of the issue. But today I received an email that stated, this is a bridge to where you get to the end of it, there's not even a place to eat. Stated, so I mean, this is a bridge to where you get to the end of it, there's not even a place to eat. Stated, so I mean, I think there's a lot to where you get to the end of it, there's not even a place to eat. Stated, so I mean, I need to make sure that we share with people what exactly the project is, what it's going to have, and make sure that the information that gets out there is accurate. So thank you all for being here tonight.
Mayor Foster?
Well, thank you. And council thanked the public, so I'm going to thank two other bodies that haven't really been thanked. I want to thank my staff and the staff of the city of St. Petersburg. We're trying to get as much information into the hands of the community as we possibly can. And you know, we have to rely upon facts, and so we will do the best we can to get the facts out to the public as soon as we can in this ever-evolving process. This is an evolving process. Because of the budgetary constraints involving. We have to remain flexible. Because of the budgetary constraints, the demands on staff are great, so I want to thank them today. And then I want to thank the city council. It was a good meeting. It was exactly what I think needed to happen. Great information came out. We heard from the public as to their concerns. We will continue to address that. But thank you for the passion of this council in asking the tough questions to make sure that you always hold this staff, our feet to the fire. And I just want to say, because there's a lot of talk about budgets, and Councilmember Dan already really, I think, hit the summation on the head regarding the uniqueness of various stages. If we can't deliver the new St. Petersburg Pier as designed or as modified within budget, it won't be built. I mean, that's just the bottom line. So when people talk about there's still, of all the puzzle pieces that we have to put down, there's still quite a few puzzle pieces remaining. There could be a vote. It could, now that we have all of the schematics, it could fail in wind testing. So all of these things, there's still a lot to do. So I just ask for some patience and kind of what Councilmember Danner said. If you simply want a building with surface parking over water, we can do that. We're good at that. We could deliver that tomorrow with little fanfare, little wind testing, and little engineering. If you want something iconic and unique that will be the brand of the city for the next 50 years, then there will be testing and the cost associated with that testing. That's the bottom line. If you want an arcade, if you want a wooden pier, if you want rides in Pier Park, if you want a Pier 33, if you want to duplicate somebody else's pier, we can do that. But that's not really what the task force challenged us to do. They looked at all of these piers, and they didn't want us to duplicate anyone else's pier. The inverted pyramid did not duplicate anyone else's pier. So we're going to, if we want to have something that is the brand, the unique brand of this city for the next 50 years, then yeah, we're going to have to test. And we're going to have to do a lot of engineering. And it's going to cost some money. But you know what? At the end of the day, I think it'll be worth it for our kids and our grandkids. And like in 1967, when they had a group called Save the Pier, and all of the arguments that you hear in 2013 were made in 1967. And it's a hoot to read some of the newspaper articles from 1967. I was 3, by the way. But it's interesting to see how history has repeated itself. But the inverted pyramid has served us very well. And I'm sure that was state of the art to balance a 60 by 60 box on caissons. Yeah, it served us well. But now we're going to create this brand going forward. So thank you, council. Thank you, staff. We're going to move forward.
I'm impressed you could read at 3. That's pretty good.
Let me finish this up with thanking the concerned citizens for asking hard questions. Imagine if on Tampa Bay Water, which I'm the city rep, if hard questions had been asked 7 or 8 years ago when they built a reservoir, we'd be $120 million farther ahead. And so, I want to thank the staff for responding to tough questions and frankly, refining the design as we go along. And so, folks, please continue to ask hard questions, because it's a lot cheaper when it's just on a computer screen than the questions you don't ask that you find out later on. We're going to take a 5-minute break, and then we're going to start City Council. We're adjourned.